Hello, it's Duncan. Here at Gilded Rose Inc. we are still investigating the use of JetBrains Expose library to allow us to persist our stock information to a Postgres database. At the moment we're saving items into a plain old text file, and that code is intertwined with the code that updates item qualities. So first today we'll look at extracting I/O from the logic. That will give us an implementation of the repository pattern, but with the twist that we always load and save all items at once. Then we'll create another implementation of the repository, just storing items in memory, before finally implementing the interface using expose talking to Postgres. We end up with a nice functional data store that doesn't mutate rows, but instead appends new versions so that we can always reconstruct old states if we need to. Let's remind ourselves once again how the stock gets loaded. We have this stock object that has this stock list method that takes the current time, and that remembers the file here that contains the list. And first thing it does is to load the items. Then it decides whether the items are out of date, and if so, updates them. And then if it has updated them, it saves them back to disk again. And then these loads and saves are implemented in terms of file I/O in sequences, which means they're nice and easy to test. Now, if we start storing our stock in a database rather than a file, this logic should still apply. We should still be loading items and then saving them. We'd just be loading and saving them from the database rather than a file. So this stock object should still be relevant. It can still be doing that part of the job if we extract the file I/O bit. And we're going to do that by introducing a class. And to start with, that class will be inside stock. So first of all, this is where we load. So let's make a method out of that, and we'll call it load. And then this is where we save, and it's saved to stock file. So let's make a method out of that. Well, it's saying we can't. Let's see what happens when we continue, and the answer is nothing. Oh well. I think this is probably because of this receiver here. So what I'm going to do now is I'm going to make this into a plain old parameter. Like that. And now let's pull this parameter out of there into a variable, and let's take this thing and make a method out of that. This is save. So now we have load and save. Let's just see what signatures are. This is returning a result of either a loading error or a stock list. And this is returning a result of the staged stock list or some sort of I/O error to say that we couldn't save it. Now what I'm going to do is make those methods of a class, and we're going to make it an inner class so that it has access to the scope of the outer class. And we will call this, for now, items. If I take those two methods and put them inside, then we need to make them public. And we'll need an instance to talk to. So we'll say val items equals items. And now this is items save, and this is items load. And we'll run on our test to check that that's okay. And it is. Now the reason this currently needs to be an inner class is because it uses this stock file here from its parent. But if we were to give it here as part of the constructor, and then add that here, and then make it a property of the items, I think that could reasonably be private, then this no longer needs to be an inner class, and if it isn't, then this stock file will be its own property here. And that would mean we can move this items class to the top level. We'll just continue there. Now this has had its own file, which is fine, but we need to move this saved to that it was using. So let's pull that out of here and into here. And run the test to check everything's fine. Which it isn't. We get this very strange no such method error saying that we don't have a constructor for our items. It took me a long time to work this one out. And it's that we have this items tests here in the same package, com Gilded Rose persistence, that has in here its own items. And it turns out that when we run the tests for our stock, this call here to item stock file doesn't resolve to this, it resolves to this one. But this one doesn't have the constructor. I don't know why something doesn't warn you about that, but let's solve our problem, at least for now, by renaming this one to be PG items for Postgres. And the test, I think, we'll rename to PG items tests. Okay, let's see whether that makes everything pass. Well, that's better. Back in what I think we'll now call stock file items. This outside function isn't now pulling its weight, so let's just inline that and run. Just to remind us what this is doing is it's backing up our stock file just in case we screw up. Our stock class now has been decoupled from how we load and save stock, but it still has this stock file property, even though it doesn't use it. We can remove that, and it just becomes a constructor parameter. But it really shouldn't be creating this itself at all. It should be passed in, and should probably be passed in as an interface. So let's just go and have a look at this again and see what that interface looks like. It has two methods. It has a save and a load. So let's extract an interface from here. And we'll extract it to a separate file, which we will call our items. And we want to take both save and load. And now look at that. We see our interface now has save and load. By the way, it's worth looking at the return type of this. Ordinarily, save would return nothing or unit in Kotlin terms, but we've had it return the stock list that it saved in order to give it the opportunity to signal an error here. So stock here, when it's saved, is returning the result of that save rather than the thing that it has saved, which should be the same thing, but won't be if there's an error. Now remember, our goal was to have stock depend on not a stock file and create stock file items itself, but to depend on an implementation of items. Let's have a look at who calls this constructor. Well, there's only a couple of places, our app and our stock tests. We could fix those up by hand, but let's practice our refactoring. What we're going to do is we're going to create a function in here with the same signature as our stock. We'll take these into here. So what we're doing is we're making a fake constructor. So it won't be values. And that is going to call our stock constructor with the file and the zone ID and the item update. And you see that can't compile at the moment because they look the same. So we're going to move this up as the property of our stock, and then take this as the thing we pass into there. And then this is items, which is items. Bit of a faff, but these places will now all be calling that function. And so we can inline this function. And having inlined it, they will now be calling this constructor, passing it our stock file items. Just need to fix some formatting, so we will put all those on separate lines, and the same in our app. And run the tests. Good. Something a little bit strange here, where we did have a reference to item updated by, and it's been replaced in here by a function, which is a little bit weird. We'll fix that by hand. I think IntelliJ was just trying to be helpful. Check that's not the same in our stock tests. And it is. Goodness me. So let's go and find the old version, which was this lambda, and we'll put it back in here and run the tests. Okay. So now our stock class is completely decoupled from our file system. We could have it talk to an items implemented in terms of Postgres. Before we go on, there's a little bit of an issue here, which is that we have to pass now into this save. Let's remind ourselves what a stock list is. It's a last modified date and a list of items. Well, we've populated the last modified with now when we did stock list updated. So I think we could fetch it out in item save. So if we go to item save here and look at our implementation, we're using this now just to create a backup file name, I think this could equally well come out of stock list last modified. Now we'll run the test to check that's true. Now they will pass, and we've got quite a lot of confidence in those. So now let's just remove that parameter from here and from items and back to stock. We don't need to pass that into there. So that simplified our interface. If the tests pass, which they do. Another little simplification here is that at the moment we are recalculating days out of date int and local date of instant now and zone ID for every item as we map. Well, we can fix that by making a parameter out of this. And this would be days out of date as the int. So notice IntelliJ has replaced the long parameter and moved this up here. We can do the same with this local date. We can move that up into item updated, and local date's fine, except that for some reason it's made it nullable. Reformat this a little bit and run. Good. And now reading this with fresh eyes, stock list isn't a good name here, but updated stock list tells us what's going on. So let's review what we've just done by way of a commit. This middle one was just a rename of an existing items in order to get rid of name clash. In stock, we're now no longer depending on the stock file and managing loading and saving ourselves. We're now delegating these items, and items is an interface here, which has load and save, and is implemented by stock file items, which has received the code that was in our stock class. And at the level of our application, the application now creates this stock file items and gives it to the stock. So at some point we'll cut over to a version of items that talks to our database. Let's commit that with extract items type from stock. Okay, so now we have stock talking to items and items being implemented by this stock file items, the one with all this file horribleness here. Maybe before we go onto a database, we could write an in-memory version of items that would be nice and simple. So let's start with a test. So here's in-memory items tests. And after last week, people pointed out that command N in a file allows us to generate a test function. And we can say that we want JUnit 5, and we can give it a name. Let's call it test for now. And we get a skeleton. Excellent. So let's use this test to force a creation of in-memory items. We'll say val items, and we'll tell it that it's an items. Is in-memory items. And then Alt-Enter here gives us a chance to create a class in-memory items. We can tell it we want it in a separate file, in persistence, and in main. And add that to Git. And because we said that this type should be items, IntelliJ has made this implement items. Of course, it doesn't implement items because it doesn't have the methods, so let's add those. Okay, that will pass because we're not doing anything, but we'll run the tests in here just to check. Good. Now let's ask ourselves, what should happen if we call load on this? So we can say items.load. And at the moment we know the answer, it will throw because of this to do. But we can say, let's assign that to a variable, and then we can say, what does our expected look like? Well, we know its type is going to be result of stock list and stock list loading error, and we'd like it to be a success, and that will have a stock list. And let's remind ourselves what a stock list looks like. It has a last modified date and some items. We can't have any items here, but we could have a last modified date. So let's say that we expect this to be a last modified date of the instant epoch, and the items to be an empty list. Just lay that out so we can see it. And now we can say assert equals expected is my result. And we'll pull in the Kotlin test version of that. Okay, run, and we expect it to fail. Still does. But we can copy this here into our load and return it to get us passing. Good. And now we know what to call this, and it is returns empty stock list before any save. Now it's bugging me that I'm scrolling left and right here, so let's inline this and this, put these on different lines, and over here we can drop that down onto its own line as well. That will do for now. Run the tests. Good. Now we'll need another test for actually saving and then loading. So I'm just going to pull this in-memory items out as the test fixture. And now we're going to need a populated stock list, and I think maybe the stock tests had one of those. Let's have a look. This is our sort of thing. So let's take that into our tests. And now we can duplicate this and call it returns last saved stock list. But we don't want to do that. Okay, so now then, we know what happens when it's empty. So before we start, we'll say items save with our initial stock list. And now if we load, we expect to see success of that initial stock list. I don't believe that can pass, but we'll just check. And I'm right because we don't have a save. Now in memory, we can implement save by just remembering the item. So we can say stock list equals stock list, where this is this dot stock list, a property that we don't yet have. So let's create a property. Now this is that it's a late init var. I don't believe it's late init. I think it wants to be a variable though, because we're going to assign to it, but it could start out as our default here. So I'm going to copy this and put it into there. And now our save wants to return a result, the thing we just saved. We could call load, or we could just return success of the thing that was passed in. Let's run the tests. And now we're failing because load is always returning this hard-coded value. I can fix that by making it return stock list, wrapped in a success. Run that. And we pass. That's nice. At the moment, this test is only showing we're returning one saved stock list. Let's create another. So we say val modified stock list is our initial stock list. Copy. And let's change two things about it. We'll change the last modified date to be the initial stock list's last modified plus, say, an hour. So we'll recognize it when we see it. And we'll set the items to be the initial stock list items without the first one. And now we'll go through this little dance. We'll say the modified stock list, and we'll check we get it back and run. Good. Now, we won't often access our in-memory structures from multiple threads, but it would be nice if they worked properly when we did. And a good way to make that work is to wrap this stock list in an atomic reference. What we can say is that this is an atomic reference of our initial stock list. Now this is immutable because we're going to change the reference inside it. So here, instead of saying this.stocklist, we're going to say this.stocklist.set the stock list we passed in. And here we're going to call stocklist.get. That should pass our tests. Now it won't deal with every concurrent scenario, as we will probably find out in an episode or so's time, but it's a quick and dirty way of giving us at least some safety. One little change I'd like to make is to give this a constructor parameter of the stock list. So this is going to be stock list is this default. Cut that out of there, put it in there. Must have been a nice way to do that refactoring, but that can go in there. And now that means that we could create an in-memory item that's already populated rather than having to call save on it the first time. Check that doesn't break anything we've done already. And we're good. Now, if you're anything like me, when we pulled this stock file items code out of our stock class, you'd have been thinking, oh, hold on a minute, what about the tests for that? we were testing these load and save through the test for stock, but now we don't have a stock file items test. Interestingly though, now we do have a test for how we expect implementations of items behave, and it's this in-memory items tests. So can we run these tests on stock file items? Well, of course we can. I covered that in a previous episode, and I call those things contracts. So what we could do is we could extract the contract out of our in-memory items tests and implement it with the in-memory items test and the stock file items tests. Let's just see how that goes. I'm going to extract a superclass out of in-memory items tests to a separate file, and we'll call this items contract. Now I'm going to pull up the initial stock list and our two tests. And this items, I'm going to pull up and make abstract. Let's see what that looks like. Okay, so now our in-memory items test is an items contract, and it overrides items to say, those are our in-memory items. Let's have a look at items contract. Well, after a bit of importing, that has all the actual tests. What we could do is we could make this items a constructor parameter. I'll pull that up into here and just make it a val. And that will allow my in-memory items tests to pass in-memory items up to the contract. Does that work? Let's run it. Good. And now we're in a position to create a new test, which is stock file items tests. This is going to be an items contract, and we need to pass it to stock file items on some file. Now for tests, it would be handy to have a temporary file. Let's see if we can remind ourselves how we do that. Here we are, look, files, create temp file. Let's click and take one of those and put it in there. Now this will be interesting. Does this pass the test that we wrote for in-memory items? Let's find out by running them. Amazing. Now that we have our in-memory items, we can use it to simplify our stock tests. From a previous refactor, this ended up using the stock file items, and that's a pain because we're working on disk and we have to use our fixture in order to initialize the contents of that file. Instead of the fixture now, though, we can have an in-memory items, and we can see here the fixture is initialized with this initial stock list, so we can put that in here. Now if we create our stock on our in-memory items, let's go down and have a look. Well, we expect this to pass. In fact, let's just run all the tests and see what happens. So update stock if last modified yesterday has failed. Well, that's because we're asking the fixture to load to check what has been saved. Instead, though, we can say items.load. And as that is a result, we'll do value or null on it. See whether that gets that to pass. And it does. We're left only with this one, which has the same issue. So we can say items.load, value or null. And in principle, we've got the same issue down here, but we're not seeing that problem because we're not actually updating the stock. So let's just put that in there and run. Good. And now if we write, fixture should be unused, and is. So we can get rid of that and run. Good. Note though that list stock tests, which is our integration test, is still using the fixture, and we'll be using the stock file items because that's what's configured in production. Let's run all the tests and check that in. Good. And now this is create in-memory items to simplify unit tests. Splendid. Okay then, the in-memory items have simplified our tests, but we can't use that for production. We came here to create a database items. So let's do that. Kotlin class for database items tests. Now we don't have to write these from scratch. We have our items contract. So this can be an items contract, and we need to give it our database items that doesn't exist yet. Ask IntelliJ to create that in persistence, and we'll put this in our main source. And here's the class, and it doesn't compile yet until we implement the members. I'll put this over here so that we can see it at the same time as the tests. Just lay this out and run these tests. Okay, unsurprisingly they fail because of these to-dos. Let's remind ourselves what this first test looks like. And that says if we start empty, then we should return a stock list that is empty and has the epoch as its last modified time. Well, we can get that to pass by copying this here and returning it from load. Let's see how that works. Now that's cheating, but it gives us something to refactor from. Now let's look at implementing save. In order to save, we're going to need a table. And we worked out how to do that in the last episode. We could say something like, we have an object that is items, which is a table. And that's an exposed SQL table. And we need columns for the fields of our item. And we had some code for that in the last episode. Let's copy it into here. Here it is. We'll just take these properties into our version over here. And last episode, we also worked out how to reset everything between tests. And we wrote this, which again, I think we'll copy and put into our new test. So that will get rid of our items table and then recreate it. But this now needs to be database items. Items, like that, and put it into there as well. So now if we run our test, we won't get any further, but if we look in the database tools, we've now got our items table, which is empty. Last time we also worked out how to insert an item, and it's here. So let's take that code, copy it into our database items, and now in here we can say save is items.insert. But we need to do that for every item in our stock list. So we'll need to say stock list items for each, and the subject of that is our item. Now this save requires that we return a result of the stock list that we just saved. That gives us an opportunity to say whether we've got an error rather than throwing. And in here we can just say return success of what we were passed. If we're being really fastidious, we might reread from the database, but I think that's good enough. Let's try running that. Still failing, unsurprisingly. And now we have no transaction in context. Now transactions are going to be a bit of a problem. We know how to create one. It's code like this. But should the test be starting a transaction, or should we be doing it inside our items? We don't have a facility for doing it in the test at the moment because the tests are actually defined in this contract. So I think for now what we'll do is we will start the transaction in here. But that's the thing we're going to have to address before we go into production. In the meantime, though, we will wrap a transaction around this, give them some database, like that. Where does the database come from? Well, I think that will be passed to the database items. So this can be a constructor parameter, like that. And not nullable, I think. And now the test will have to give it a database. And we have one of those lying around here, which came from our items test, which we'll fix up later. I can go in there. Let's try that. Well, now we're failing because our load is returning this hard-coded stock list and not one read from the table. Let's go and fix that. Back in our test from the last episode, we worked out how to return all the items from a table. And it looks like this. So again, we'll copy that. Go back over here, paste this code. And this is going to be items all. And all of these are our items in here. So now when we load, we can go and get our items. All. And now if we have no items, then we want our empty stock list. Else, we want a stock list with some last modified date. Don't know yet. Let's use now. That won't be true, but it will compile. And the items we've just read from the database. And we need to return that here and wrapped in a success. And I think we could pull this return out of my if. Let's see how far that gets us. Oh no, everything fails, and that's because we forgot the transaction. So let's wrap that around just this little bit for now. So we say my items is a transaction in the database that fetches all our items. Try again. Inexorably further, what's our issue now? Well, now we have the right items, but the wrong last modified. And we're going to have to think about how to solve that problem because we don't currently have anywhere in the database to record this timestamp. Now we could create a table just for that timestamp and update it. But I propose to do something more subtle, and that's to add a timestamp to each of the items as we save it. So I propose this give us a last modified, which is a column of instant, and is defined as a timestamp with the name last modified. Now, if when we save our stock list, which is here, for every item, we're going to set its last modified to be the last modified for the whole of the stock list. So now when we save a stock list, we'll have a row in the database for each item, and each one of those rows will share the same last modified date. So we better get them back as the set. What does it look like in code? Well, when I load, I want to do the equivalent of select star from items, where last modified is select max last modified from items. So we find the latest last modified in all the items, and we'll pull back all the items with the same value. And that will be our current version of the stock list when we load. On reflection, I don't like last modified. I'm just going to change this to modified. Okay then, how to implement this logic in Exposed? I think it is possible to run raw SQL in Exposed, but getting the results back is a little bit tedious. What I've come up with in the end is to do this in two parts. One is to run the select finding the max modified time, and the other is to run the select getting the items back. Let's do the first one. Our last update is we'll go to our items table, and we're going to slice that. And we're going to get back the items, modified, and we're looking for the max. We can call select all on that to bring back the results, and we know there should only be one of them. And we can get the value from that with get or null, asking for the expression that we selected on in the first place, which is that. Well, let's have a look at the type of that. It's a nullable instant. Well, that sounds promising. Let's move this into our transaction. And now we want to say that if our last update is null, then we want to return our success with the empty stock list. Unfortunately, we can't do that here because we can't return out of this block here. Transaction isn't an inline function. What we can do instead, though, is return this expression. And the result in this case to be success. Otherwise, and I think you have to hold your nose for a moment, we're going to return success with this last update. And now we need to query the items, select where the items modified equals the last update, and then map that to item. Now there's a chance that if we get rid of this and this, we can make it compile. Seeing where the problem is, that's okay. That binds with that, which is good. That binds with that. What is our issue here? It turns out that we haven't put a stock list in here. Lay that out. A little bit horrible, but let's run and find out how we did. Wow. Now that's fake surprise, really. Obviously, this took me quite a while to work out. Documentation for Exposed isn't complete. It took a few visits to Stack Overflow to get where we are here. I'll tidy up a bit before we go on. It could be nicer if this was a variable. Then we can make this one line And that would be true if we took these out as well. And now I think lay this out as slice, select all, first or null, get or null, and run one more time. Good. And maybe lay this out the same way. In fact, if we made this a function, we could call it all items updated at. And this could also be a function of last update. And now if we use let, calling this last update, we can move this block here, take this out of here, put in the Elvis for null, and take out that. It was a bit of a bodge, wasn't it? But question mark dot let there. So this says, get the last update. If that was null, then we have success with an empty stock list. And if it wasn't null, then we can use it to go and fetch all the items updated at that time. That helpfully means that this is a single expression, as I think is the one up here. And run the test. Good. Now one last code change before we finish for the day, and that is to add an index for this last update, as we're both finding the max and we're querying by it. So we go down here and we can say that our modified has an index, and we'll use whatever the default name is. Run one more time, and it succeeds. Taking a look at what we've done then, we've created this database items, which passes all the tests in our contract. It takes a database in order that it can set up transactions, and maybe we're not entirely happy with the way those transactions are working, but they will do for now. And we come up with a scheme where when we save, each item is tagged with the last modified of the stock list, and that means when we load, we can find all the ones with the latest version of that and return them as our current stock list. Having a table that we only append to is also a good thing because it keeps all the history. So if we have messed up our updates at any point, we can go and find all the old versions of our items. You might be wondering what happened to the event sourcing we were talking about a couple of episodes ago, and the honest answer is I don't know which of these two approaches to choose at the moment. I'm just gaining familiarity with Exposed and Postgres. So let's commit this with add database items. And I think we'll call that work in progress to signal that we're not ready to go to production yet. Wonderful. In the next episode then, I think we'll look at what to do with these transactions. And as a bit of a teaser, I plan to try out both the new Kotlin context receivers and also a reader monad. So if you're interested in either of those things, then please subscribe to the channel, maybe hit like on this video, and consider buying the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook. We're getting lots of good reviews, many of which are saying you should buy it even if you don't know Java or do already know Kotlin. Thanks for watching.